Solving equations by balance gives you the means to answer really quite complicated equations, performing just a bunch of quite simple operations. So it's a fantastic skill. Now, when you start, you might be tempted to solve the equations just by inspection, just by looking at them and spotting the answer. But I encourage you to try and get out of the habit of doing that because there'll be some that you can't spot the answer to, and you really need to just learn this as a new technique. Now, just like when we looked at solving equations by flowchart, we're thinking about what opposite operations exist. It's almost like we can imagine how this expression was created. What happened to this x? It's almost like it was dressed up or put in disguise. Well, the first disguise it put on was it got multiplied by 2. So x became 2x after it was multiplied by 2. Okay, what happened to the 2x after that? Well, then it had 5 taken away from it, didn't it? And that turned it into 2x minus 5. Now, we want to basically strip away both of these disguises from the x until we end up with just x equals something so that we can see. And we need to treat this like a set of scales or a seesaw and keep it balanced at all times. So whatever operation we do to one side, we need to do to the other side to keep it balanced. So we want to sort of disappear things one bit at a time to strip things down and get the x by itself. Now, I can see that here we have multiplied the x by 2 first and then subtracted 5. Because if we'd subtracted 5 first, and then we'd multiplied all of that by 2, it would look like this, wouldn't it? Which is quite a different thing. So the first thing I want to undo is the last thing that got done. It's a little bit like getting dressed. You put your socks on and then your shoes. You can't take your socks off first. You have to take off the shoes because they were the last thing that you put on. Well, the last thing that was done here was minus 5. So what's the opposite of minus 5? Plus 5. Now, there's a bunch of ways you can set this out. Some people like to say, hey, I need to add 5 to both sides. And what they do is they'll go 2x minus 5 plus 5, we'll add 5 to that side, equals, it's nice to keep your equal signs under each other, I think, 3 plus 5. Now, can you see here that I've kept this balanced because all I've done is I've added 5 to both sides. On the next line, you can tidy up. If you've got minus 5 and plus 5, that equals out as 0, doesn't it? So the only thing left here is your 2x. And on the other side, 3 plus 5 is 8, so you get down to there. Now, I prefer a different setting out. I think this takes a long time and it's a bit boring to do. I prefer to put down just a little note to myself of what I'm doing, almost like a grace note in music, if you're familiar with those. Plus 5 here, plus 5 there. That way I can see that the plus 5 and the minus 5 are going to cancel away here, and all I'll be left with is the 2x. And I can see that 3 plus 5 is 8. Now, one advantage of doing it this way is, what if I had different numbers here? Let's imagine I had some nasty sort of numbers, like maybe I've got 117 there equals 229. All right, the first thing I need to do here is to add 117. Now, I can easily see they'll cancel each other away, disappear each other. But over here, if I'm adding 117, I can be kind of cheeky and line the columns up. And now I've just got a little addition algorithm. I can do 9 plus 7 is 16. I can do my carrying even, and I can do my working there easily to figure out what number needs to be on this side. And it's much more straightforward than if I'd written out 229 plus 117, which as soon as I've got my numbers side by side, sure, I can add them together, but I'm more likely to make a mistake. So I like this method. It's less writing, and it keeps the numbers above each other, which is much easier to add and subtract them that way. Now, back to our simple question that we had. I think we were subtracting, what was it, 3? I can't even remember now. Equals 5. So we said, let's add 3 to both sides. No, it was the other way around, wasn't it? Not that it really matters. I think it was like that. Okay, so now if I add 5 to both sides, I get 2x is equal to 8. All right, you can probably spot the answer at this point. 2 somethings are 8. Gee, what could the something be? It must be 4, because 2 4s are 8. But instead of just writing down x equals 4, let's learn the good setting out, because that'll help us when we do a tricky one. What's happened to this x here? Tell a story. Well, it's been multiplied by 2. Okay, what's the opposite of multiplying by 2? Dividing by 2. So the good setting out is to say, hey, I'm going to divide this side by 2. Why? Well, because then these will cancel. That'll disappear the 2's, and I'll just have x by itself. But hey, I've got to keep things balanced. If I've divided this side by 2, I have to divide that side by 2 as well. Okay, now I can tidy up. This side just has the x, and that side, 8 divided by 2 is 4. Now, that seems a little bit clunky, and perhaps some of you are thinking, that looks messy, why didn't you just write x equals 4? Well, I'll show you. This method comes into its own as soon as you've got an answer that's going to have a fraction in it. Okay, a trickier example now where the good setting out is going to make this really easy. First step, let's try and disappear this plus 3. We can do that by subtracting 3 from both sides. And actually say it in your head as you do it. Subtract 3 from both sides. So this side won't have 3 on it anymore, you just took it away. It'll just have the 7x on it. And this side is 5 minus 3, which is 2. All right, what's happened to this x? Well, it's been multiplied by 7. How do we undo that? Divide by 7, but you've got to do it to both sides. All right, the easiest way to divide 2 by 7 is literally just to write divide by 7. The answer is now looking at me. It's 2/7. But this side looks a bit messy. If you've got x and you've multiplied it by 7 and you've divided it by 7, these cancel each other out. We have the x all by itself. So at this point, it's nice just to write your answer out nice and tidy. X equals 2/7. Okay. Now you can always verify if your answer is correct by subbing it back into the equation. So if I have 7 lots of 2/7, well, that's actually going to give me 2. And then if I add 3, that does give me 5. So I can verify that it's correct. A trickier example now. Now remember that you need to think about what you're going to disappear first. And it makes sense to think about how this x has dressed up in the beginning. So here, the first thing that's happened is the x has been multiplied by 4. How can I tell? Because it's closely bound to that 4x. They're sitting right together. All right, what's happened to the 4x? Well, the next thing is they've been divided by 3. Okay, now what's happened to the whole 4x divided by 3? Well, it's had 2 taken away from it. So the last thing that's happened is this minus 2. So it's the first thing to disappear. How do we disappear a minus 2? We add 2. So I write it as a little note to myself. I'm going to add 2 to both sides. Now if I add 2 here, I just won't be minusing 2 anymore. I'm just going to be left with this part, the 4x minus 3. Again, I'm keeping my equal signs lined up if I can. And 1 plus 2, that's easy to do, 3. All right, tell the story again. What's happened to this x? Well, it got multiplied by 4, and then they got divided by 3. The last thing that happened was divide by 3. How do we undo divide by 3? We times by 3. Okay, now setting out here, you can do it lots of different ways. You could rewrite the whole thing like this and times both the sides by 3, if you like. I tend to think that that's wasting a bit of time. I would tend to just multiply both of these sides by 3 right here. Let's say, let's times this guy by 3, and let's times all of this by 3. Easier and simpler. Okay, over here, the 3's are going to cancel, because if you've got 4x, whatever that is, and you've divided it by 3, but you've also times it by 3, those 3's cancel. And that's the whole purpose of why we times it by 3 in the first place. Now we've got the 4x by itself, so write it out on its own, and I know that 3 3's are 9. Okay, this last step is often the same. X has been multiplied by 4. How do we undo that? Divide it by 4. But you have to keep things balanced, so you do the same thing to both sides. And look, my answer is looking at me. It's 9/4. These are going to cancel. So x is equal to 9/4. Now you can leave your answer as an improper fraction. That's completely fine. Or if you prefer to change that to a mixed numeral, and you can easily work out that that's 2 1/4, go ahead and do it. You can then substitute this back into the original equation to check that your answer's actually right.